We talked a little bit yesterday about how you set up and work with the hyperbolas, or I'm sorry, with the parabolas. The questions they gave you on the review packet were written in that vertex form. I will always ask for you guys in standard form, and I think we talked about these enough yesterday, so I don't really worry so much about that. As you get into the rest of this side here, kind of what I want to do today is just make sure that we hit a couple of each of these styles to remind us of how these things work. And then again, towards the end, give you guys the last bit of time to ask extra questions and things of that nature. I'm going to go out on a limb and assume that we're okay on graphing and writing out ordered pairs for circles. I think we're okay on that one, right? Okay, so let's flip around to the next side here. I talked about this also on number 10. Number 10 is awful with the denominators. Before I printed, I forgot to proofread before I printed. Remember, the worst values that you guys were dealing with when we're working with ellipses or with the hyperbolas with your A's and B's, those generally tended to be stuff that worked out to be nice square roots. 16, 9, 25, 36, 49, something along those lines. It was always that C value that tended to be a little bit messier. I would kind of leave to be the same way going forward. The suggestion that I've made for number 10, just so you guys, for extra practice-wise, change it to like 16 and 25. You know, and work it through that way, or 36 and 49. I probably, the worst root stuff that I'd give you guys as far as your A's and B's are going to be concerned would be something along the lines of one of them being, you know, like the square root of 8, and the other one being a perfect square, something like that. But usually it's been pretty straightforward. So what I'm going to do is just work on number 9, walk through all the expectation of how you set it up and what your values are going to work out to be, and then 10 and go from there. Now, every single time that we've done one of these problems, I've always set it up the same way. The very first thing that we did is we always identify the center. We identify the H and K, and we build off of that. In this case here, my H and K is 1, -3, so that's my center. I also know that this problem was an ellipse because it said graph the ellipse. So what I'm going to do is look at my calculator and look at the ellipse equation. Now, when I'm dealing with an ellipse, I have to remember that the a squared term is the larger of the two values. In this case, what is a squared equal to? 16. So I'm going to list out a squared is 16, b squared is 1. C squared then, well, if it's an ellipse, is it a squared plus b squared or is it a squared minus? Very good. So c squared is 15. Notice I have not drawn a graph yet. I'm just listing all of my parts. A squared was 16, therefore A is plus or minus 4, B is plus or minus 1, and C is plus or minus root 15. Okay. The A value, no matter what conic we're talking about, is always the distance from the center to your vertex. Your B value will be the center to your co-vertex, and your C value is always going to be your center to your focus. So now it's just a matter of plotting your center and walking around. 1, -3. With this ellipse, the a squared term was underneath the y squared, if I'm not mistaken. Yeah. So I know it's got to go that way. Go ahead. Since I know that it's going to be opening upward and downward, when I go to walk my value of A, I'm only changing the y coordinate of my vertex. So I go up 4 from here, and I go down 4. So my vertices are now at 1, 1, and 1, -7. I'm listing them while I'm plotting them, so don't forget where they are. Co-vertices, B value, distance from center to co-vertex. My co-vertex has a B value of plus or minus 1. Now I'm changing from the center, I'm moving it left and right, which means I have to adjust my x value. I add 1 and I subtract 1. 2, -3, and 0, -3. There's my ellipse. The last thing that I have to do is plot and list my focus, because the ellipse does not have the asymptote, so I don't have to worry about that part. My focus value is the distance from the center to the focus, well, excuse me, the C value is the distance from the center to the focus. Now, if my ellipse is moving up and down, what am I changing, what am I adding to, the x or the y coordinate for the focus? It's moving up and down. The y coordinate. So when I list out my focus points, I'm going to have 1, comma, -3 plus root 15, and 1, comma, -3 minus root 15. There. And those are my focal points. And I'm done. That's everything you have to be able to do. It's, again, the math that's involved here, the arithmetic, adding, subtracting, and taking the square root. Really all there is to it. The only parts that you had to really remember here is if it's a squared plus b squared, or if it's a squared minus b squared to find that c value. There's your ellipse. So let's write the equation of 1. Use the information to write the standard form of the equation of an ellipse. Let's look at 11. Whenever we had to write the equation out in the standard form of an ellipse, the very first thing that we did is that we plotted where the vertices were, or the co-vertices, or the focus, it doesn't matter what, to give us a visual representation of the direction that it's going, so we know which equation to use. So if my vertices are at 9, -9, and -3, -9, what direction is this ellipse opening? Or is it going? Is it vertical or is it horizontal? It's horizontal. So when I look at my equation, my standard form of an equation for an ellipse, that means I'm working with the a squared term is underneath the x squared. Are we okay with that? Now that I know that much, I need to find the center. The center occurs at the midpoint of the vertices. Well, the center also occurs at the midpoint of the focus. It also occurs at the midpoint of the co-vertice. In this case, I'm going to use my vertices because that's what I've plotted so far. Since it's on the same horizontal line, which of the ordered pairs, or which value of the ordered pairs will also be in the center? The x or the y coordinate? It's on the y. So I know that my center is going to be at something -9. To figure out what the x value is, all I have to do is take -3 plus 9. What do you get? What's half of that? There's my center. So right now I have x minus 3 quantity squared plus y plus 9 quantity squared equals 1. All I have to do now is figure out my a and b, or a squared b squared. The value of a, remember, is the distance from the center to the vertex. We can find that real fast. How far is 3 from 9? What's 6 squared then? Are we okay with that? Center to vertex, that value is 6. That means that value is a. Now I have to figure out my focus. Notice what they did here with the focus. They have 3 plus root 11, 3 minus root 11. Yeah?
You have x
Oh, thank you. What did they do to the 3 value for the focus? Very good. They add and subtract the square root of 11. That means that the distance from the center to the focus was the square root of 11. Therefore, what is C equal to? C is the square root of 11. I know that A is 6, C is root 11. We now know that A squared was 36, C squared is 11, and now B squared is? And the reason that I know that B squared has to be 25 is since this is an ellipse, there's a plus sign between the two fractions. That means that A squared minus B squared is C squared. So 36 minus something is 11. It's 25. You're done. Something. B.
Cuggy. You didn't hear me, did you?
No, we play rock about 30 seconds.
That's just hyperbole. Hyperbola.
Is it you? I'm so
Did you
close.
yet? It's actually 30 days away, Mark.
But who's counting?
That's gonna be pretty cool. When it's
Next ones we have.
Can you do 13?
Sure. We have the hyperbolas. Snapping at us?
She called me a blondie again. I'm not even going
Shoe fits.
Oh, that didn't.
If the shoe fits?
No.
to. Just two guys is.
Can't just go like this.
Because that's not
I can't even drink water.
It's like.
All right. Again, in this problem, we know it's got to be a hyperbola. Why? Because of the minus sign. So right off the bat, we're going to take our calculator, pull up the hyperbola general equations, slide it over here, and which of the two values comes first, x squared or y squared? The x squared comes first. So the x squared comes first, which means it's got to go left and right. So I just quickly draw that so I know what it's going to look like in the end.
Oh, this one, yes.
If I know that's what it's going to look like in the end, what do you think the first thing I'm going to do again is going to be?
Find the center.
Find the center.
Yeah.
So my h and k
1.
is at 1, 1. A squared is how much?
9.
B squared is 1. C squared, therefore, is 10. So I have to add them with the hyperbola. So if a squared is 9, that means a will be plus or minus 3, b is plus or minus 1, and c is plus or minus the square root of 10. Now I'm going to start plotting. Always list these things first, guys. It just makes it easier in the long run. I go to 1, 1. I know I have to open left and right. My A value is the distance from the center to the vertex. So if I'm moving left and right, that means I have to move left and right for my vertex. Move to the right 3. Move to the left 3. 1, 2, 3. Gives me vertices at 4, 1, negative 2, and 1. Covertices, therefore, go up and down. The B value here was 1, so I add 1, subtract 1. What was it 1, 0, 1, 2? Okay. Asymptotes. Put in your asymptotes.
Do you
What's that? We will eventually have to use point slope to write the equation. Since this was an x squared first hyperbola, is it b over a or a over b? B over a. Because remember, it's yab a dab a do. So I know my slope is going to be b over a. So your slope here would be plus or minus 1/3. Yes, sir.
Or you could just count the rise over
You can, but not always is it that clean. All right, it's not always that clean.
Yes, I think this situation.
oh yeah.
Sure.
Like, face.
Stop driving them along.
Yeah.
No, he's not here. Yeah. All right. So now your C value. This remember your curve is always going to open up to the C value. Always going to open to the focus. So here, if it's going to be going this way and this way, which coordinate of the ordered pair am I going to have to add C to? The x or the y coordinate? The x coordinate. Very good. So that means my focus is going to be at 1 plus root 10, comma 1, or 1 minus root 10, comma 1. And it's about here and here. And I'm done. Oh, forgot my equations.
Yeah.
Yeah.
That's what I was gonna ask.
I almost forgot, yeah.
Wait,
We've already, sorry.
Sorry, you do that from the center.
Yes, always from the center. C is always from center to focus.
Okay.
Sometimes you're adding to the x coordinate, sometimes you're adding to the y coordinate. It depends on the direction
Where
of
are
the
we
curve.
going?
Just like Morgan said, we've already identified what our slope is, but we have to write the equations of the lines of the two asymptotes. So now we're going to use that slope, but with what points are we going to use? Center. Very good. So our last thing with the hyperbola is that we're going to use y minus 1 equals 1/3 x minus 1, and then y minus 1 equals negative 1/3 x minus 1. So you get y equals 1/3 x plus 2/3, and y equals negative 1/3 x plus 4/3. And those would be our two equations of asymptotes. Hyperbolas have a ton of stuff that you have to label and put down. You have your vertex, covertex, focus, and the equations of the slant asymptotes. Yes, sir.
If it's really clean on the test, do you care if we just
Oh,
You
yeah.
know there's gonna be 4/3.
Oh, I mean, no, because you don't always know if it's 4/3 or not. Well, what I'm saying is, what happens if you, I think one of the other examples, it gave us an intercept at like 0,4. I think it gave you the y-intercept on the other problem.
Yeah, but like this one you can kind of tell because like the center and then it's 1/3 over. You can completely tell.
I wouldn't do it that way.
Why?
Because what happens if it was, like, 5/8?
Yeah, that's hard, but I'm saying like if it's 1/3 of this, you know it's minus 1/3.
These points will be 2 seconds.
I'm just saying you might need those. Yeah. For the test.
If it's down to 2 seconds, you're not done yet.
It doesn't take 2 seconds. That's you over-exaggerated that hyperbole.
Yeah. Good.
At least 10.
That's how I roll.
No, I'm seeing you on burn.
Bonjour. Paul's like, what time is it? I'm going, is it June? Paul's going, is it?
They're making a high school musical 400.
Why?
That would mean that I would had to have seen 1 and or 2 or 3.
That was a third one.
And they made
Think
3
about
and a
it.
half
So about it.
last year.
Did you hear that?
What?
They're making a 4.
Yeah, I know.
Yeah. I heard that.
Is Zark Efron in it?
grow up watching High School Musical.
No,
Was it like the prime of your childhood?
no, must have been deprived. But you know what? I'm okay with that. I've survived. I'll get over it. Again, now we're going to write the equation of a hyperbola given vertices and covertices. So what we're going to do here is figure out what direction it's going, to know which one comes first, x squared or y squared, and then fill it through. Again, you have vertices, -2, -3, and -16, -3. So if my vertices are horizontal from one another, what direction is this open?
Not sure.
Correct. Try to make it come straight across from one another. I know it's going to have to do this. Okay? I know that has to occur. Again, if I know that has to occur and they're going to be horizontal from one another, that means they're going to share the same y value again. Which means I know my k value is -3. Now I just have to average -2 and -16. Quick, -2 plus -16.
14. No, plus -2, 18.
What's half of -18?
-9.
You may come back to class.
Oh, and I didn't get in trouble. There was a fight earlier, and I stopped a kid from going into it.
Oh, yes.
You punch him in the face.
Nice.
Look at you fight.
So, do you guys notice something here? Look at my center. And look at the ordered pairs for the vertex and co-vertex. Notice how the k value is the same for the vertices and the h value is the same for the co-vertices?
I noticed.
It works. Sometimes you pick up on that, you can figure that out. So now all you have to figure out is what's your distances. How far away is -9 from -2? 7. A is 7. The co-vertices were at -9 and 3. How far away is -3 to +3? 6. So B is 6. I know enough. I don't have to worry about C's or anything here. I'm just going to look at, if it's a left or right hyperbola, what goes first, x squared or y squared? X squared. It's really fast when you set them up this way. So it's x plus 9 quantity squared minus y plus 3 quantity squared equals 1. 7 squared is? B squared, 6 squared is? That's all you gotta do.
Wait, how do you get the 16?
How do you get the 6?
Yeah.
I know that from the center of the -9 and 3 to go to a co-vertex, -9 to +3, the only thing that changed was the y value. So how far is it from -3 to +3? 6. I just quickly walked through that.
Alright.
All right. I could have gone the other way and gone down to the -9, going from -3 to -9, also got the 6. Yeah.
On the actual test, when you have like a graph so that we can just, so are we like drawing it out ourselves?
I've never given you a graph.
Like,
The only time, all right, you will have graphs when I ask you to graph and label.
Yeah, so this then. you would-
Something like this, no, you won't have a graph.
Okay.
Because when we did this, we've always rough sketched. When I'm asking for the specifics, what's your center, your locus, all that kind of junk, I did put I want to say it's a 20 by 20 or a 25 by 25. I gave plenty of space because those are the types of problems you have to do all the completing the square and all that other kind of junk to go through it. So I gave you guys plenty of space. I'll probably give you a separate sheet of paper. You go through it. Okay? One of the problems that most people are coming across here when it's getting down to classifying the conic and solving through is number 18. I've seen this problem wrong a bunch of times today, so I'm going to try to make sure you guys see it again. When you're going to classify the conic, that means that at some point in time you're going to have to do some completing of the square. Which means you want to get both your x squareds and your y squareds kind of grouped together with the constant on the other side. So by doing that, I'm going to move and put the y squared plus 2y minus x squared plus 2x equals 16. We all right with that? So I'm going to start the setup to complete the square. Y squared plus 2y plus blank. What do I have to do here?
Negative
Gotta take the negative 1 out. Good. So the one on the y squared term, I didn't have to take out anything. So I know it'll just be 16 plus something plus negative 1 times something for my placeholders. Now the rest is easy. What's half of 2?
1.
What's 1 squared?
1.
So I have y plus 1, quantity squared, minus. What's half of negative 2? What's negative 1 squared? What's 16 plus 1 minus 1? 16. What's your shape? Is it a circle? It's not a circle. What's the symbol in between the two?
Oh.
It's a hyperbola. It's a hyperbola. Most people are getting that wrong because they say, oh, it's a circle because the A and B are the same.
Merv, so that means the negative 1 you factor in the whole thing.
Yeah. What happens here is that in a hyperbola, a squared and b squared can equal the same. Instead of having a rectangle, you went up the square. It's okay. Yeah.
Isn't it plus 2x? Or x squared plus 2? Or is that
You already factored out the negative 1 to get negative 1 times x squared minus 2x blank. Remember when we had stuff where it was, if it was negative 2x squared plus 4x blank in order to complete the square, you had to take out the negative 2 first? Same process.
Okay, so
I just took out a negative 1 instead of a negative 2. This winds up being a hyperbola because of the subtraction symbol. A squared and b squared can be the same value. That's okay. It just means that your rectangular box becomes a square and your slope is 1. That's all. That's the only weird one that's been coming up today. The other one should work out relatively easy. I will tell you on 19, do we all agree right off the bat when you're looking at 19, it has to be a parabola? It has to be a parabola because there's only one term that's squared. So what I'm going to do is move things around to get the squared term by itself. Y squared equals negative x minus 3. It's almost looking like the form for a y squared parabola. Remember, y squared parabola is y minus k quantity squared equals 4p x minus h. When you look at your calculator, which means what do I have to do to the negative x minus 3 in order to get it in that form? Take out the negative 1, yeah. So you have y squared equals negative 1, x plus 3. So what's your h and k?
negative 3 and 0.
Yeah, negative 3 and 0. And what's your p value? Good. From there you can plot. It's y squared. It's y squared with the negative p, so which direction does it go?
It goes down.
Left. Just trying to be funny. These, the systems, those numbers should all drop out rather clean without too much of a hassle, I'm hoping. But are there any other particulars I kind of skipped around on these things you want to see real fast? I'm giving you guys time to just ask extra questions. We have about 15 minutes. So. Yes, sir.
On the task, can we just grab them or are we gonna have to write the coordinates out?
Coordinates, yeah. Just like we've been doing, I'm going to have a spot. I actually put a spot on there that says vertex blank blank, co-vertex blank blank, you know, things like that. So that way it reminds you to be specific for everything. As well as the, if, I also wrote in there,
I'll do it.
what are the equations for the slanted asymptotes if needed? Some of, because if it's a parabola, you don't have it. If it's the other one, you know, if the ellipse doesn't have it. You guys should do well in this. This is very straightforward stuff. You don't have to memorize anything. Yabba dabba
Oh,
do.
we can use our calculator?
Everybody can use their calculator except Richie.